In the annals of military history, some weapons transcend reality, existing as monuments to sheer engineering madness. Among them, none is more gargantuan than the Schwerer Gustav. A railway gun so colossal it dwarfed anything before or since, designed to shatter the strongest fortifications on Earth with steel and fire. Weighing over 1,300 tons and standing 4 stories tall, it was the ultimate expression of Nazi Germany's industrial megalomania. Today, we dive deep into the origins, engineering, and final fate of the largest caliber rifle weapon in human history, the Heavy Gustav. The story begins in the mid-1930s. The French military had completed the Maginot Line, an impenetrable wall of steel, concrete, and artillery blocking any German invasion. To bypass or crush this barrier, Adolf Hitler personally ordered the German High Command to request a weapon capable of piercing 7 meters of concrete. The task fell to Krupp of Essen, Germany's legendary weapons manufacturer. Krupp's chief ballistics engineer, Erich Müller, began calculated drafts for the weapon. Müller calculated that to deliver the required destructive energy, the gun would need a caliber of 800 mm and a barrel over 100 feet long. Hitler visited the Essen foundries in 1936, approving the project and demanding that the monster gun be completed to support the planned invasion of France. Named in honor of the head of the Krupp family, Gustav Krupp von Bohlen und Halbach, the weapon was officially designated Schwerer Gustav. The dimensions of the completed cannon were staggering. The barrel alone weighed 400 tons and measured over 105 feet in length. The entire structure stood 43 feet tall, 72 feet wide, and stretched nearly 150 feet from breech to muzzle. Because of its massive weight, no single railway line could support it. The Gustav had to travel on 2 parallel sets of tracks. It was mounted on 4 massive bogies, containing a total of 80 wheels, distributing its weight across the dual rail beds. The breech mechanism was a wedge-type block, operated by massive hydraulic lifters that locked the enormous shells into place before firing. To aim the weapon, there was no traverse mechanism. The gun could only aim up and down. Horizontal aiming required moving the entire gun along a curved track. Special double-track curved railway beds, known as skiskurv, had to be laid at the firing site to allow the gun to be aimed left or right. Powering this steel beast required a dedicated generator train, providing electricity for the crane's hydraulic pumps and automated loading mechanisms. The logistical tale of the Schwerer Gustav was an army in itself. Assembling the gun at a combat site required nearly 3 weeks of labor. A force of over 2,000 soldiers, railway engineers, and technical specialists was assigned to erect the weapon and lay the dual tracks. 2 giant gantry cranes, traveling on tracks outside the gun's main railway, assembled the carriage, bogies, and the barrel piece by piece. Security was paramount. 2 battalions of anti-aircraft artillery were deployed around the clock to protect the gun from Allied airstrikes. Chemical troops were also on standby, equipped to lay massive smoke screens to hide the giant gun from reconnaissance planes. The entire operation was commanded by a major general who coordinated the transport, defense, and targeting of the artillery unit. The ammunition used by Gustav was equally terrifying. It fired 2 types of shells, each the size of a full-grown elephant. The concrete-piercing shell weighed 7.1 metric tons, consisting of hardened Krupp steel with a small explosive core. The high-explosive shell weighed 4.8 tons, designed to devastate surface fortifications and leave craters 30 feet wide. Propelling these massive shells required up to 3,000 pounds of gunpowder packed in brass cartridges and silk bags. Firing the gun generated a recoil force so immense it pushed the entire 1,300-ton assembly several yards back along the rails. The pressure inside the barrel was so intense that the rifling wore down rapidly. The barrel could only fire about 100 rounds before needing replacement. Although designed to smash the Maginot Line, the French surrendered before Gustav was ready, leaving the gun without a target. In early 1942, the German army faced the Siege of Sevastopol, a heavily fortified Soviet naval fortress on the Black Sea. Hitler ordered the Schwerer Gustav to be deployed to the Crimea to break the Soviet resistance and pulverize their coastal forts. Erection of the gun began in May 1942, requiring a special railway trench to hide the assembly work from Soviet spotters. On June 5, 1942, the Schwerer Gustav fired its first combat round. The roar of the gun shook the entire Crimean Peninsula. Over the next 12 days, Gustav fired 48 operational rounds. 1 shell struck Fort Stalin, completely destroying the reinforced bunker. Its most legendary shot targeted the Wycliffe ammunition magazine, buried nearly 100 feet under the seafloor of Severnaya Bay. The 7-ton shell pierced through 30 meters of water and meters of solid rock, detonating the ammunition magazine and sinking a ship in the harbor. Following the fall of Sevastopol, the Gustav was disassembled and shipped to the northern front near Leningrad for another planned siege. The siege was cancelled, and the gun spent the next 2 years in storage as the tide of the war began to turn against Germany. A second railway gun, named Dora after the engineer's wife, was also constructed by Krupp and briefly deployed near Stalingrad, but never fired. As Soviet forces advanced into Germany in 1945, the German High Command ordered both giant guns to be destroyed to prevent capture. Allied troops discovered the charred, blown-up ruins of Dora in the forests near Grafenwöhr, Bavaria, in April 1945. The remains of the Schwerer Gustav were found shortly after in Saxony, having been demolished by its own crew with heavy explosives. The scraps of these engineering behemoths were eventually melted down in post-war steel mills, returning to the industrial cycle. The Schwerer Gustav represented the absolute physical limit of conventional, gunpowder-propelled artillery. The development of tactical bombers and long-range ballistic missiles made these massive railway guns obsolete before the war even ended. Today, only scale models and historic photographs remain of the Schwerer Gustav, a symbol of military hubris and terrifying engineering. While the Gustav was designed to be the ultimate weapon of the German army, it was also highly vulnerable to enemy action. Because it was so massive, it could not be hidden easily. This is why anti-aircraft and smoke screening units were absolutely essential. Every shell fired by the Gustav cost thousands of Reichsmarks to manufacture, making it one of the most expensive weapons programs of the war. The steel barrel of the Gustav was a masterpiece of Krupp metallurgy, requiring months of forging and tempering in Essen. When the barrel rifling wore down, it had to be shipped back to Essen, a massive logistical undertaking. The second gun, Dora, was named after the wife of chief engineer Erich Müller. It represented a slight refinement of the original design. Dora was briefly set up near Stalingrad in late 1942, but Soviet encirclement forced the crew to quickly disassemble and withdraw it. A third railway gun, the Schwerer Gustav, was also designed. It was intended to fire smaller 520 mm shells at a range of up to 100 miles. The Schwerer Gustav was never completed, as Allied bombing raids on the Krupp factories in Essen destroyed the key components. The destruction of these giant railway guns marked the end of an era of German military engineering. When U.S. troops first discovered the wreckage of Dora, they were stunned by its sheer size, questioning if such a weapon was even practical. Soviet engineers thoroughly documented the wreckage of the Schwerer Gustav, taking measurements and steel samples back to Russia. Many historians argue that the resources spent on the Gustav would have been better used to build hundreds of tanks or fighter planes. Hitler's obsession with super-heavy weapons often overrode practical military strategy, leading to colossal wastes of industrial capacity. The transition from conventional artillery to rockets, such as the WWII, marked a paradigm shift in long-range warfare. Today, visitors to military museums can only marvel at the scale models of the Gustav, reflecting on the destructive hubris of the era. The Schwerer Gustav remains a terrifying testament to what happens when industrial power is combined with unchecked military ambition.